Hi! In this lesson, you will learn about correlation and how data is related. In the last lesson, we learned that linear regression creates a line of best fit that expresses the closest linear relationship between all data points. It's important to note that these linear models are only useful on data that is correlated. Correlation determines the strength of the relationship between numeric values. In other words, it determines whether or not independent and dependent variables have a relationship to one another. Correlation is often represented as numeric values from -1 to +1. A value of +1 means that numeric values have a perfect positive correlation, and a -1 means that the values have a perfect negative correlation. A value of 0 means that there's no correlation, or no relationship between the two variables. So what exactly does a perfect correlation mean? Perfect correlation means that as one variable changes 100% of the time, the other variable will change the exact same amount. Let's look at an example. Here we have a data set that shows the number of computers compared to the amount of energy that each computer uses. As we can see, the data follows a distinct pattern. As a new computer is added to the system, the amount of energy that is being used is increased by 200 watts. Each time we add a computer, the same amount of energy is being used. Because a dependent variable changes the same amount at the same rate, this data is said to have a perfect correlation. As a result, the linear model will predict the correct energy used per computer every time. In real life, however, it's very unlikely that data will perfectly correlate, as there are always other factors at play. In this example, energy use may spike if too many computers are on a certain electric grid, or decrease depending on the type of computer that is being used. If data has a perfect correlation, chances are there might be something fishy with the data. Data can either be positively or negatively correlated. This is determined by the sign of the correlation value. A positive value means that the data has a positive correlation, and a negative value means the data has a negative correlation. Positive correlation means that as one variable increases, the other variable increases as well. It also means that as a variable decreases, the other decreases. A negative correlation suggests that as one variable increases, the other variable decreases. In both positive and negative correlation, the relationship can be determined by looking at the data on a graph and analyzing the direction of the line of best fit. Data can have no correlation. This means there's no relationship between the two variables. When there's no correlation, linear regression will not provide useful predictions because there's no associated patterns between variables. Before creating a linear model, it's important to determine if the data is correlated so that the model will actually provide useful predictions. The closer the correlation is to 1 or -1, the more accurate the linear model will be to predicting the expected results. The value associated with correlation can be calculated using something called Pearsons correlation coefficient. This is a statistical equation that seeks to determine the variability of a variable, or how standard it changes, compared to the product of their standard deviations. The end result is how correlated two variables are from 1 to -1. For the sake of this course, we just need to know that this algorithm is capable of providing us with a correlation coefficient, not how the formula works. It's incredibly vital to understand that just because two variables are correlated does not mean that two variables are related at all in the real-world context. Let's take this graph for example. It shows the relationship between the number of pirates on Earth to the global average temperature. When run through Pearson's correlation, the correlation coefficient is -0.93. This means that there is a very strong negative correlation between these two variables. As one increases, the other decreases. In this case, as the number of pirates on Earth decreases, the global temperature decreases. This statistical correlation, while interesting, has nothing to do with what actually is happening. Of course, it seems odd to think that pirates are directly responsible for global warming when other things like carbon emission, electricity, and greenhouse gases have been scientifically linked to global temperature increases. While they are correlated statistically, these data points are unrelated otherwise. The pirate population is not causing the global temperature to change. When two variables are correlated, but clearly unrelated, we say the relationship between variables is spurious. So how can we tell if one variable is caused by another? Firstly, we need to determine if there's an observed association. In other words, Is there a statistical correlation between the two variables? If we were to use the pirate example, this would pass this first check, as the correlation score was very high. We also need to prove that the independent variable occurs before the dependent one. This is a little bit more tricky to understand. For example, suppose we wanted to measure the role that confidence plays on how successful someone is. It'd be hard to determine which came first. In some cases, people's confidence grows as they become more successful, not the other way around. If we can't prove that the independent variable comes before the dependent variable, then we can't prove causation. Lastly, we need to be able to rule out other potential causes, or determine if the relationship is spurious. If there are other more likely explanations for why data is changing, such as global average temperature, then it's unlikely that the correlation we've established is going to provide any meaningful data. Now that you've learned about correlation, it's your turn to look at some examples.